All right, let's keep working with vectors, and we are going to talk about what we call the dot product. So the dot product means multiply, between two vectors is a real number. It will not be a vector. So what we're going to do is I'm going to give you the dot product of two vectors. We're going to multiply them together, and what we're going to end up with is one numeric value. Alrighty, so dot products are used to determine the angle between two vectors. They're going to derive geometric theorems, and we are going to solve physics problems, like the one with the wagon. That's a hoot, right? So our dot product says, if we have AB, we have vector U, and it's in component form, it's AB, and vector V, and it's in component form CD, and I tell you we're going to do U dot V, then how we find that number is U dot V is A times C, and then you are going to add that to B times D, and that will give you one number. The sum is one number. So the sum is going to be a number. It'll be a singular value. It's not going to be a vector. It won't be anything in component form. All right. So let's take a look at how that is going to look. So let's find the dot product of each of these. Let's take the first one, U dot V. So the rule says we're going to multiply the horizontal components together. So I am going to do 2 times 4. I'm going to multiply the first parts together, and then I'm going to add that to the product of the vertical movement. So then we're going to have 8 minus 3, and that's 5. Boom. We don't need it just in component form. We can do our dot product if we're looking at our unit vectors. We can take 6i plus 4j dot negative 2i plus 3j. Please keep in mind, I and j are not variables. I and j are not variables. When we multiply with these, we're not going to make it I squared and j squared. As a matter of fact, I'm going to ignore the I and j altogether. Let's write this as a component form. Let's write it as 6,4 dot, use the right notation please, dot negative 2, 3. So there I've got my vectors in component form. So we're going to multiply the first parts, 6 and negative 2, and we're going to add that to the product of the second parts, 4 and 3. So that's going to give us negative 12 plus 12, which is a dot product of 0. A dot product of 0. Not so bad. Now then there's a couple properties of these dot products. Basically what they're saying is that if you do U dot V, that's the same as V dot U. Dot product is commutative. We can also distribute it. U dot V plus W is the same as U dot V plus U dot W. We can distribute on the other end. It's commutative when it comes to multiplication. So if I say scalar times U dot V, that would be the same thing as saying scalar times U dot V or U dot scalar times V. Either of those. Doing a dot product with 0 is 0, and if you do U dot itself, that's going to give us the magnitude squared. Boom. So not bad. And then we can use this. Why do we care about dot product? Well, we can use the dot product to find the direction of our vector. So if theta is the angle between two non-zero vectors, so I'm going to give you two vectors. Neither of them are going to be a 0, and theta is between 0 and 180. Then the following holds true: the angle between those vectors can be found by doing U dot V all over magnitude of U times the magnitude of V. So that's what we are going to do with this. So how the geometric interpretation of our dot product is going to look is like this. Let's find the angle theta between this pair of vectors. So we have one vector at 3, 4 and another vector for 2, 1. And if you don't remember, right above here, we said we are going to do u dot v. U dot v. So that's going to be 3 times 2 plus 4 times 1. I like putting them all in front of me. All over magnitude of u times the magnitude of v. Oh man, how do we find the magnitude? Well, why don't we back that up? Remember, the magnitude of u is the length of u. We talked about this in previous videos, is a squared plus b squared, the square root of a squared plus b squared. Oh, boom. So we're going to find the magnitude of u. That's the square root of 3 squared plus 4 squared. So that's going to give me 9 plus 16. That's the square root of 25. So the magnitude of u is 5. And now I need to find the magnitude of v. The magnitude of v is going to be the square root of 2 squared plus 1 squared. So that's going to be 4 plus 1, the square root of 5. So the magnitude of v is the square root of 5. Don't freak out because it's a radical. Nobody cares. It is what it is. We deal. So we're going to have 3 times 2 is 6. 6 plus 4 is 10. So on top, we're going to have 10 over 5 radical 5. And this is what the cosine of theta is. That's what we're trying to find. And I'm like, I hate 10 over 5. That reduces to 2 over radical 5. We hate square roots on the bottom. Just hate them. Old man yells at cloud type hate. So 2 radical 5 over 5. So to find theta, we are going to take the inverse of cosine of 2 radical 5 over 5, not on the unit circle. So I'm going to bang that into my calculator, and we're going to find out that theta is about 26.57 degrees. And let's make that and about, let everybody know I rounded. Boom. That's not so bad. Let's do B. So B says we're going to do u dot v over magnitude of u times the magnitude of v. Why don't we just, right off the bat, why don't we find the magnitude of u and v? So we're going to do 2 squared plus negative 6 squared. So that's going to be the square root of 4 plus 36. So square root of 40. And so that's 2 radical 10. V, the magnitude of V, is going to be the square root of 6 squared plus 2 squared. Hey, look at that. That's going to be the exact same thing because 30, we're just ignoring the sign. So you know what? I am going to take the information I already know, and I'm just going to write that down. Boom. So now let's do our dot product of u dot v. So that is going to be 2 times 6, first times first, plus second times second, over 2 radical 10 times 2 radical 10. So on top, I am going to have 12 minus 12. Wait a minute, 12 minus 12, that's 0. So 0 on top, and I don't care what I get on the bottom. It'll be 40 on the bottom, but that's 0. So the angle between these, because what we were finding this whole time is the cosine of theta. With all of that was to find cosine theta. It's actually to find theta. So the cosine theta of 0. So to find theta, we are going to do the inverse cosine of 0. Inverse cosine of 0 is theta is 90. So the angle we're talking about is a 90-degree angle. And then before I end this video, I want to throw one more new term at you. Orthogonal. Orthogonal is a fancy way of saying perpendicular. So if I tell you have orthogonal vectors, that means the vectors are perpendicular to each other. We already saw an example of orthogonal vectors. I and j are orthogonal vectors. Orthogonal. Why? Because I is a horizontal movement. There's I. And then j is a vertical movement. They make a right angle. I and j are orthogonal. So on application problem 8, this is a little tricky. I'd be very impressed if you could get it. Why don't you try it? Try it. Come in, try it. And if something doesn't work, try it again. Give it like a good 15-20 minutes of your time. See what you got. And then come into class and ask questions, and I'll love to help you out. So I'll see you when I see you, Gauchos. Hope we're having a good one.